Hello everyone, Cliff here in my shed again. I've just made this resettable dial for my ml7 crosslide. I made one a little while ago, this one out of aluminium. I actually made it a little bit too small. It was alright, it worked alright, but it was a bit rough as well. I didn't make it particularly well. I'm going to keep that one and probably put it on the top slide. This is the original ones that come off it, and they're not resettable, so they're a bit of a pain in the arse. So these are the component parts of it. Now the only difference I did on this one compared to the original was the camera's going to pick that up, that little indent in there, and the purpose of that, on the nut bit that goes onto the lathe, onto the actual thread of the cross slide, I've got this little hole here which takes this little bit of, it's the spring, it's a 2.5mm hole, and I've got a little 2.5mm ball bearing that goes in there, and it's the spring out of a disposable or a clipper lighter. It's the one that holds the flint in, and basically that spring pops in there, the little ball bearing sits on there, just launched that one across the workshop. I've only got one left. Better be a bit more careful with this one. It just pushes down. We'll get that nearly there. There you go, it's just so much harder to do things on camera. Now the reason I put that little recess on there is to stop the outside ring sliding back. I didn't do that on this one, and when you're using it, it tends to slide back a bit. It's no big deal, but it's just a bit of a pain in the arse. So there it is. That's it in a nutshell. The only other thing is it's got this little hole in here on the 0 where I put the markings on it, and that lines up with a hole in the main body, and then you can get a little bar or a drill bit, and you can use that to tighten it up when you're putting it back on the lathe. Okay, I'll stick it on the lathe and show you on the lathe. While I do that, this is another refinement to it. I put this recess in the nut part of it, and that's to take this little thrust bearing. I bought this on eBay. It's a needle roller cage, and that just fits in there, and it slides over the lead screw on the cross slide, and that just gives you a little bit more ability to tighten it onto the thing. Takes up a little bit more of the play. Obviously it doesn't take any wear up in the actual screw, but it takes up any play between the screw and the handle. Right, I'll stick it on the lathe and show you it on the lathe. There's him on the lathe, and there's the graduations. Moves quite nicely. Doesn't catch. Yep, all in all, I'm quite happy with that. So, if you want to waste half an hour and watch how I made it, that's to follow. Alright, so this is where we start. This is to make the outside bit of the dial. So this is a bit of 40mm stock. I'm just going to chuck it up and try and get it as good as I can in the chuck. I'm going to mount this up. And get it swears ready jog. The old jog feature on here comes in useful. So within half a foul, so that'll do with that. So one of the iron sights from making this one was I made this bit all in one hit. Bored it out where it goes over the nut part of it, and that made it really difficult to hold it in the chuck when I get it over to the milling machine to, what would you call it, engrave the markings on it. So this one I'm just going to face it off, take it down the 10mm I want down to there, then that'll leave me a 5mm bit when I do part it off. Put the knurled edge on. Now I'm going to do that, then take it over to the mill, do the graduations on it, then bring it back over here, try and get it squared up, and then bore it out. So for now I'm just going to mount up my poor man's DRO, so I know when I've gone 10mm over here, face it off, centre drill it, bring it down to 36mm. And zero me poor man's DRO, pull it back a bit. So I want about 3mm of it. Could be 2, but I'll give it a measure. .79. I'll get 36 up on me. 36 on me caliper, zero it, change it to inches. It tells me I want 26 thou off it. So I'll stick 13 on me cage and set him off. .95, and that's got .02 out, so that's close enough for me. So the next thing to do is get it over to the mill and start doing the graduations. I'm just going to give it a bit of a papering, just to try and get the finish reasonably decent, because once I put the graduations on it, that'll be this face finished. I'll do a little bit more work on that. Right, so this is where I got to last night. I've got the bit turned down to 36mm. I mean, the reason, I don't know whether I've explained this, but the reason it's 36mm is because That's the size of the old one, the one that was on the ml7. This is my rotary table. I think this is a Warco HV4. I don't know what it is because it actually came with a mill when I bought it. I've got all sorts of stuff off the blower. I really did get a bargain when I bought this whole chap. Like I say, it came with all sorts of stuff. But like I say, I think this is a Warco HV4. It's got a 90:1 ratio, which, if you don't know, means you've got to turn this handle 90 times to turn the chuck round once. And I've got the part in here all squared up. It's probably about half a thou out if I get round the other side. I don't know whether the needle's showing on the camera. Let me zoom in on the needle. Yeah, I've had it round. I mean, I've already done all this. It's, as you can see, it's pretty spot on. Anyway, so like I was saying, this is a 90:1 ratio on this rotary table. So basically, to get 100 divisions on the workpiece, which is what I need, I've got to turn this handle 9/10 of a turn. So I've got a indexing plate in it, and the outside edge of this indexing plate has got 20 holes. So basically I've got to go around 18 holes. Now the vector arms on here, around the normal way, they don't go close enough. They cover up more than 2 holes. So I've got to do it slightly wonky. If I get that one in that hole, I've got them apart for the two holes I need. So basically I've got to turn the handle clockwise, get it in that vector hole, get in that index plate hole, and then move the vector arms anti-clockwise, then come round again, do that, well, I've got to do that 100 times. But before I do that, of course, I've got to get the bit in there and get it all set up ready for it. I'll move him out of the way. This is the engraving bit I'm going to be using. It's an old end mill where the end was knackered. I don't know if the camera is going to focus in on this properly, but let me get a bit of paper and see if I can show you. As all I've done is ground it off to a point, and then ground half of it off, and that's going to be me engraving bit. It worked fine on the aluminium. Whether it'll work on the EM1A so much, I don't know, but well, I'm going to be giving it a go. I'm not going to put that in there yet, because first of all I've got to square everything up to it. So firstly I need to get where the centre of the cutter to the centre of the material. So I'm pretty fortunate with this machine because I've got a DRO on it. And I'm just going to wind this up, get it underneath the cutter. Right, I'm just going to use a drill bit upside down in here. Pull the y-axis out a bit. Right, so what I'm going to do is just put a cigarette paper up between the drill bit and the work, and just wind it in slowly, moving the fag paper about until it snatches it like that. And then up here on my DRO, which is a marvellous thing, I'll just zero the y-axis. I only needed to press that once, it was on Imperial. Zero the y-axis and then back to the plate. Right, well now I'll just lift the arm right up. Whack the y-axis right across. Drop my fag paper. Bring it back down again. Make sure I've gone over far enough. And do the same again. Just move this fag paper about and until it just catches it. And then back up to the DRO. So the beauty of this DRO is, as you can see, the y-axis has moved on 41.775 millimeters. But with this DRO, it's got a little halve button here, so I can press that, press the Y, press the right Y, and then it will bring up exactly half of whatever that measurement was. So basically I'll bring the head of the tool back up so that drill bit's out of the way. Now wind the y-axis back until it gets to 0. And that's put the centre of that directly over the centre of that. I love this DRO. It can even make an old bodger like me a reasonably accurate machinist. So that's the first thing we've got set to 0. So now I want to take this drill bit out. I probably ain't got enough room. Put him back in his hole so I don't lose him. And now I'll just tighten up the engraving bit in the cutter head. So now that is directly over there. So now I'm going to lock the y-axis off so that there's no travel front to back, because that I don't want it to move anymore while I'm doing this. Now I'll set up the x-axis. I'll bring this down with the main until it's pretty close. I'm going to just bring it down till I can just eyeball it. Just so the point of that is in line with the edge of the material. And again, back up to the DRO and 0 the x-axis. So now I know that that's where the edge of the material is. When I move it along when I'm doing my cuts, I can read off of that the length of them. The last one remaining is the z-axis, which is the up and down axis. Alright, so I can move the x-axis as much as I like now. I've got my 0 set. I'm just going to lift the arm of the actual whole head up, which runs up and down on the pillar, and then I've got the fine adjuster. Got the fine adjuster just here. So I'm going to pull this back a bit, just a little bit, just so I can get a touch off on the, and switch the machine on and just wind it down with a fine adjuster until I just get it touching off. Right, I don't suppose the camera's going to pick it up, but it's just made a tiny mark on it, so that's touched off. Wind that forward, and then again back up to the DRO and 0 the Z axis. So with the cutter away from the material, 2mm away from it, I can put a bit of cut on it. Not quite sure how deep to go, probably a couple of thou, which is what, 0.05 of a millimetre, about there. We'll try that one, 0.55. And that's it, we're ready to make the first cut. I'm just going to switch the machine on and using the DRO come up here 6mm. I'm going to do the 10s on this 6mm. I'm going to do the singles 3.5 and the halves 4.5, but let's see how this cut is to start with. I think that's alright. I think could probably do again just a little tiny bit deeper. So I'm going to move it down another . I moved it down to 0.65, let's give that a go. Alright, that's fine. So, for the next one, so I've got to take this round to that one, shove it in there and move the vector back to that so I know where the next one's going. And if Ian Matthews is watching, that's what I think them bits of brass you had in something you got in some tools or something. That's what I think it was half of one of them vectors. Right, so this one I'm only going to go 3.5mm. bring it around to the next one. And the next one. Right, this next one is going to be one of the 5s. So I want to do that 4.5 mil. Alright, so that's as good as I'm going to get a look at that now. Right, so anyway, that's the first 5 done, another 95 to go. So I'm going to turn the camera off now and I'll clock the time and see how long it takes me to do these. We'll be back.